Good morning, everybody. Welcome to class this morning. Today we're going to talk about computer hardware for our content. But before we get into that, just a couple of announcements. I still have your Module 2 assignments to finish grading. So I'll be looking at those over the next day or two to get those finished so you can have your grades ready and back to you. This week we're working in Module 3. Remember, those Module 3 assignments are going to be due by Sunday at 11:59 p.m. And just while we're talking about assignments here, just a quick reminder that in the table of contents for that module, it shows you everything that's graded in the module. And remember that all of your readings, all of your videos, all of that stuff is graded. It does have a grade attached to it. So after you do the reading, after you watch the video, you need to make sure you're clicking that attempt button to take the little quiz that goes with it and making sure that you're submitting that so the grade gets pushed forward. And that the other things, remember that the open-ended stuff is stuff that I have to grade manually. So I'll go in afterwards and give you the grade for that. And the discussion boards I grade manually. And remember that those are kind of strict. So you want to make sure that you are really answering those questions and making good comments to the fullest of your ability. And again, if you have any questions about any of this stuff, just send me an email and we will answer your questions to the best of our ability. So today we're talking about computer hardware. And you might be wondering to yourself, well, why do I need to know this stuff? Why do I need to know about computer hardware? I'm never going to be, a computer repair person. I'm never going to make my own computer. I don't need to know about any of the internals that really makes the computer tick. But I want you to learn about computer hardware, and this is the reason why I want you to learn about computer hardware. Because, nowadays, as we've kind of discussed it before, no matter what job you have, you're probably going to have to use a computer, and that computer, at some point, is probably going to break. Something's going to go wrong. There's going to be some kind of issue with it. And remember that all of that downtime, all of that time when you're not able to use your computer, is time that could be spent making money. So you're losing money. You're losing the ability to work, and as such, losing money for either yourself or your company, as long as your computer is not functional. So when we think about computer hardware, what we really want to be able to do is we want to kind of be able to determine kind of what's going on when things go wrong, and from there, be able to communicate these things to that computer repair person, to that help desk person, whomever you're working with that's going to help you solve your computer issues. That's the big deal there. Right? So, again, I don't necessarily want you to be somebody who knows enough about computer hardware to be able to build your own computer or become a computer repair person. I don't care about any of that. But I do want you to know enough about it to where you can communicate your computer issues fluently, because that gets problems solved faster. On top of that, you might want to buy you a new computer one day. And knowing what all the hardware components are and what they do helps you make better, more well-informed decisions as you make a purchase. So you're like, oh, if I do a lot of video editing, or if I do a lot of photo editing or graphic stuff, I'm going to need a computer with a better graphics card, a faster processor, more RAM, so we can have all of that stuff kind of together and known. So that's the point of this module. That's those two key things there, what I really want you all to get out of this current module. So one of the things that we talked about, I think I might have, yeah, here we go. One of the things that we kind of talked about last week was what constitutes a computer. Right? Computers come in all shapes and sizes. and we talked about this 2 weeks ago. Computers come in all shapes and sizes. There are a lot of different things that are computers, but they all are computers. Whether it's a desktop, a laptop, a tablet, your mobile phone, whatever you're using is one of these devices that we utilize to put in data and get back information. So our main components of our computer fall into these 4 essential categories. And these 4 essential categories kind of build up what we call the system unit. So our 4 essential categories here are the CPU. You might also hear this called the processor, the memory, and we'll talk about the different types of memory that we have, and the difference between memory and the last thing here, which is storage, which is important, and the network adapter. There are obviously a whole lot of other components that go into a computer, but these are our 4 big ones that make up what we know as the system unit. All computers have these 4 components in them. They might not have some of the other stuff that we'll talk about, may or may not, but they definitely have these 4 things. But in order to talk about all these computer parts, we need to start talking about where they all live, and that's the motherboard. So you might have seen the motherboard, could also be called a system board. There are a couple names for these that you might hear thrown out there. This is that one sort of central hub that we can hook things into that allows for, the electrical impulses to get from different hardware components. And, it's sort of the home where all of your computer hardware lives. The main circuit board in our computer, that's what the motherboard is. And on this motherboard, we basically have everything, right? It's where the CPU is, it's where the memory is, it's where external device ports are, like for your monitors and USB devices. And the motherboard uses what we call a data bus. Data bus, not a term you'll probably ever use again. You can actually see the data buses on your motherboard. We can kind of see some of them in this graphic here, where we have these kind of copper channels that are in the motherboard that kind of, and these are the things that route the electrical impulses, which are our data, from one component to another component. And the size and speed of these buses contribute to the performance of your computer. On our left-hand side of the monitor here, we have a picture of our expansion slots. And these are PCIe expansion slots that we see in the picture here. There are a couple of different types that you might find in a motherboard, depending on, how old your computer is and things of that nature. It's in these expansion card slots where we plug in expansion cards that are additional circuit boards that add to the functionality of our computer. And, it's where we kind of plug in our add-ons, our extra stuff. So if we want some more USB ports, we don't have enough USB ports in our computer, we can get a USB expansion card and stick it in one of these expansion slots. Maybe our onboard video isn't good enough for the types of applications that we want to run. We can take a video card and put it in one of these expansion slots. These expansion slots are just what we use to kind of add a little bit of functionality onto our base motherboard. So from here we have the CPU. The CPU is, you can kind of think about it as sort of the brain of the computer, if you will, if we want to kind of oversimplify that in a few terms. The CPU performs the processing cycle, or the data cycle, the thing that we talked about a couple weeks ago, where we bring data in, we run it through calculations. We said we run it through a process. And then on the other side, it spits out our information. So the process is controlled by the processor, the central processing unit, or CPU. And a term that you might hear a lot thrown around in terms of processing is parallel processing. And the ability to have parallel processing means that there are essentially multiple microprocessor chips. You might hear them referred to as cores in your CPU. And this allows for multiple calculations, multiple instructions to be processed simultaneously. So if I have a single core processor, then I can process one instruction at a time. If I have a 4-core processor, I can process 4 instructions at a time. Hi, yes, this is chapter 3 that we're looking at today, module 3. Yeah, thanks for the question. You know, if I have an 8-core processor, I can do 8 cores at a time. 16-core processor, which is about the highest you can find out on the market right now, 16 instructions at a time. Now, on top of that, I have my clock speed. And so the clock speed is how fast I can do one of these calculations. Hi, yeah, no worries. Thank you. That's what this is for, just so you can ask some questions. So thank you for your interaction. No worries. So we have our clock speed, and that kind of goes hand in hand with our cores. So our clock speed is essentially how fast we can do one of these calculations. So you can see a processor that has 4 cores and a 3.2 gigahertz clock speed, let's say, or 16 cores at a 3.2 gigahertz clock speed. And that means that, that 16 core processor, they're doing the processes at the exact same speed, but that 16 core processor is doing more processes at a time. So when you're looking at a computer and you want something that's a little bit faster, if you have things in different price ranges, you can look at that gigahertz speed on the processor and look at that in conjunction with how many cores that processor has in order to determine which one has a faster processor and can process more instructions at a given time. Now, when we get into a CPU, one of the things that you don't really have to know a lot about is the cache memory. It's the other 2 bits there are parallel processing and how fast we can perform the instruction cycle. That helps you make some good decisions about what to purchase, so you can have an understanding of what's faster and what's slower. Our CPU cache memory, that's just some different places where our CPU stores data temporarily while it's working on it. So like our level 1 cache is built on the chip, so it's kind of the last place that the data goes before it's processed. Our level 2 cache feeds into the level 1 cache, and our level 3 cache feeds into the level 2 cache. So essentially we're kind of taking data and pushing it up the ladder into different phases of memory while it waits to be processed. Now, data, of course, isn't going to sit very long in these caches because, we're talking about billions of cycles per second, billions of calculations per second in our processor. So we're not having things sit in these CPU memory caches for very long before they're transferred up and processed and sent back out. Speaking of memory, that's another thing that's a big deal in our computers. Our motherboard has two types of memory that we typically have to concern ourselves with. And these two types are ROM, or read-only memory, and RAM, or random access memory. And these things are similar in architecture, but in terms of how they work, ROM and RAM are very different. ROM is used for storing instructions that do not change. These are instructions that are just kind of, that's why it's read-only, right? There's no writing to your ROM. It can just read from it. But these instructions that it uses on the read-only memory are critical. So that's why we don't want to change any of it. They're critical to getting your computer running. Things like the BIOS. BIOS stands for the Basic Input-Output System. Or UEFI, which is an acronym for the Unified Extensible Firmware Interface. So the UEFI and the BIOS are kind of the same thing. The UEFI is a more modern version of a BIOS. But these are just instructions that your computer needs to just boot up and get started. We have to have something that kind of tells the processor how to push data around all of the hardware on our motherboard, so everything can get started and get running and get moving. If we don't, if it doesn't know how to do that, it doesn't know how to start things up in the right manner, you're going to have a big problem. Your computer probably isn't going to run. So we need these instructions on our motherboard to kind of be able to tell it how to be a motherboard. And we definitely don't want these instructions to be changed, because if they are changed, then they're going to break our computer. So we put these, so the manufacturer puts these in read-only memory to make the access for change non-existent, and the software being able to run right at boot up. On the other hand, is something that you've probably heard of before, RAM, random access memory. This is, This is temporary memory that stores data and instructions while the computer is processing. So we talked about that cache memory on the processor. So even though the data is not sitting in those caches for very long, we still, oftentimes have a ton of data that we need to process, or a ton of data that we need to kind of have in reserve just in case we need it while we're using a piece of software. And that's what RAM is for. Right? It's this temporary storage area where we can put all of the instructions that the computer is processing. So then it can go and get little bits at a time and pull them into those cache memories that we talked about on the last slide. So it just goes to RAM, grabs a little bit, processes it, sends it back to RAM, just in case it needs it a little later. Grabs a little bit of data, processes it, sends it back. Grabs a little bit, processes it, sends it back. Just in case it needs it at a future point while you're running the software. Because, you think when you boot up Word and you're using Microsoft Word to write a paper or complete an assignment, the instructions to run Microsoft Word have to be in the background and operating all the time, or else it'd stop working. Right? So we have to have this RAM to store all of these instructions, to store all of this data, so our computer can process it, and allow us to do the things that we want to do. Here are some ports. And some of these ports you might be familiar with, like, of course, the headphone port, where you can plug in a pair of headphones. Our USB port, so you can plug in USB devices. This USB port in our picture here, in particular, is a USB 3.0 port. So it's a little bit faster than a standard USB 3.0 or a standard USB 2.0 or earlier port. I can tell that this is a USB 3.0 port because, one, it is blue on the inside, and that blue on the inside denotes that it is a USB 3.0 port. And if you look really carefully here at the symbol that's kind of embossed in the case, you can see that it has the USB symbol that's here at the top. It looks kind of like, kind of like a weird pitchfork kind of thing. But then underneath that, it has the SS, which I believe stands for like super speed. It's kind of weird that was the way that they chose to kind of denote USB 3.0, but that's the symbol for it. But the big giveaway is the blue interior there to that USB port. And you might have heard like, oh, nobody ever gets the USB plugged in the right way every time. A little trick to that, since we can see it in this picture. We kind of have this solid bar here at the top, and it's open underneath. If you look at your USB devices, you can see that the USB plug-in has a similar setup, where it has a solid bar on one side, and it's open on the other side. So you just want that solid bar to be in the opposite position to make the two solid bars kiss as you insert your USB device. So if you ever wonder, well, how am I supposed to plug this thing in? That's it. Then we have a couple ports here for external monitors. We have an HDMI port, which you're probably pretty familiar with HDMI. High definition media interface, I believe, is what HDMI stands for. You use that for your modern televisions and stuff nowadays too. It's a later addition into PCs because, we're basically adopting the technology from the media, television, that sort of thing, and bringing it over for data transmission on two computer screens and the like. The other external monitor port we have here is what they call a VGA port. There are several other types of ports that you might see on your computer. DVI, display port. You just want to be cognizant of which ports that you have, so you know how you can more easily connect to an external monitor. And finally, we have the network card here, just shown. Network card, or we'll call it NIC, a little later on another slide. This is where you plug in your Ethernet cable so that you can connect to the internet. And then the one that's not labeled here is a power adapter port here on the end. See if I can find my mouse. There it is. That's a power adapter port. So that's where you'd plug it in. Speaking of power supplies, there are all sorts of power supplies that you can see that run to your computer or your different device that give it power. Standard power cord, that's easy, that's understandable. You take it, you plug it into the wall. The battery, which you'll more often see that in portable devices, things like your laptops, your tablets, your mobile phones. And then portable charging. Having those battery packs that you can take with you to charge on the go. We also have this charging station here, and you might have seen these before. The charging station like we have in our picture here. And we see that in a lot of newer mobile phones. I think the iPhone had it starting around Model 7. Android phones have had it for a while. There are several other devices that have this sort of wireless charging in it. And this is actually called key charging. QI. That's how we spell that. And it's a wireless charging interface to where, you know, you have one of these pads, like something similar to what's shown here. I think that one's actually being shown there is an IKEA model. And it transmits the power through the base into a special receiver in the phone. So that's what we see here. Let's talk briefly about these input devices, because you're probably really familiar with a lot of these input devices. Things like keyboards, mice, touch screens, scanners, and like document readers, microphones, things that do voice recognition, like your Amazon Alexa here. And then other input devices like your VR headsets or your game pads. Anything basically that you can do to somehow put some data into the computer. So really, when we think about it, like, regardless of what kind of input device that we use, every input device utilizes just electronic impulses. Just electrical signal. You know, we talked about binary in the past and how binary is basically just ones and zeros, ons and offs. And even in something like a digital camera, all we're doing is sort of sending some data. You know, when you look at a sensor on a digital camera, you see tiny, you know, millions of tiny red, green, and blue sensors. And if it senses red light in a particular area, it'll pass back a 1 for that sensor, and if not, it'll pass back a 0. And so when we pull out from there and we see the video that's finished, what we get is a picture, because we have all these little tiny red, greens, and blues being mixed together in different amounts. And that's more or less how things on your TV screen, things on your computer screen, your phone, your tablet, you know, any kind of digital screen like that, more or less how they work. Like, if you've ever gotten like a drop of water on your monitor and you saw, you know, all the little, you know, it does the magnification and you see the little red, green, and blue pixels. That's more or less what's happening. You know, we have, you know, hundreds of tiny little, or really millions of tiny little pixels on our screen, and they're all red, green, and blue, and when we put them together in different combinations, we get different colors. We'll kind of gloss past some of this stuff here with our keyboards and our mice, because this should be stuff that you're relatively familiar with. You know, like your regular keyboard, your stylus that you use on touchscreen devices, your mouse, a touch-enabled keyboard. All of these things are good for you to use to get data into the computer. You know, they're our most standard stuff. Touchpad, you're probably familiar with the touchpad. You know, it just senses your movements and moves the cursor around the screen just like a mouse. Touch screens. I think we all know about touch screens. Touch screens are kind of ubiquitous nowadays. We can't go anywhere without seeing or interacting with a touch screen, which is kind of, you know, worrisome in the current environment, if you will. The fact that everybody has to touch all the screens. But nonetheless, we see these everywhere. There's a little capacitive layer of material below the main screen. And that capacitive material is able to register your touch and translate it into – electrical impulses, data. all sorts of different scanners and data readers here. A standard scanner, which is what we see here. Just a standard document scanner. Something that you could take, put a piece of paper on, runs a little light over it, and based on how the light reflects, gives back a picture that's digital. I mean, when we look at a lot of this stuff, like when we look at like these QR code, well, not so much of the QR code, but especially with like the barcode reader, like we have here, or barcode readers like we have at the stores. When it comes to the scanner and the barcode reader especially, what those things work on is just the reflection of light. So when you think about a barcode reader, like, you know, and you think about a barcode, the bars are black and the area surrounding the barcode is white. And so as the lasers shined on it, certain parts of it reflect back, certain parts of it get absorbed. And that creates a pattern of binary kind of ones and zeros sort of situation that our scanner can read and interpret. Biometric devices is what's being illustrated in this picture in the upper right. Biometrics is something that has to do with your body. So in this case, they're using a face scanner on their phone to, you know, do facial recognition. But this could also include like fingerprint scanners, iris scanners, things of that nature are biometric. A lot of the future of stuff is in these RFID chips and readers. And really, it's something that's been around for a long, long time. But we're only now starting to implement them in new and different ways. Essentially what we have with an RFID device is it's just a little chip that contains a little bit of data on it, and then it has this big coil of essentially copper wire that one acts as an antenna and two helps to power the device. So if you think about it, if you've ever had to like go to a building where somebody needs to badge in or use some sort of like key fob to get into a door, the thing that is in those badges or key fobs is one of these RFID chips. And so when it gets in range of an RFID reader, the RFID reader actually powers that little RFID sticker or chip wirelessly through the antenna, that copper coil, and then that chip is able to send the data that's on the device to the reader, and then the reader determines if that's a good code or a bad code in terms of whether or not it's going to let it in. So lots of interesting stuff here with different types of scanners and readers. Let's see, our time is running a little short, so let me find something good for us to finish on. Let's jump to storage. Let's jump to storage so we can talk about that before we depart today. So at the most basic, the smallest thing that we store is a bit. This is the smallest unit of digital data. And we get the term bit from a binary digit. So if it's a binary digit, it's a bit. So it's going to be either a 1 or a 0 in terms of that whole binary thing that we talked about previously. And in order to get a character, an actual number that we can do calculations with, a letter, a symbol, we need a group of 8 of these bits. And we call a group of 8 of these bits a byte. So 1 byte represents 1 character. 8 bits in a byte, 1 byte in a character. And we have all types of file storage sizes. Kilobyte being 1,000 bytes. Megabyte being 1,000,000. Gigabyte being 1,000,000,000. Terabyte being 1,000,000,000,000. And just growing from there. And I believe petabyte might be the next one, if I remember correctly. So when you hear about these different types of storages, you might hear like 500 gigabytes versus 1 terabyte. And you're like, oh, well, 500's more. But it's not. It turns out it's only half the amount that the terabyte can store. So this is something that, we kind of have to be aware of as we're making purchasing decisions and that sort of thing. On your computer, you might have seen something like this, where you have these different storage devices. And we use these to read and write data to and from. We often refer to these colloquially as drives. So what we see here is several drives in a Windows 10 system. A C drive, a D drive, both of those being hard drives, or maybe solid state drives. A BD-ROM drive, which is Blu-ray disc read-only memory. So a readable Blu-ray drive. So you can watch some nice high-def movies, I guess. And then a USB drive or a flash drive. And so all of these count as drives on a system because it's where we can do reading and or writing data for the long term. That's the big difference between storage and memory. And some people might use those terms kind of in conjunction with one another, like to mean the same thing. But they're not, right? Like memory is short term. Storage is long term. So let's cover these really quickly, and then we'll call it a stream for today. The hard drive or hard disk drive, HDD. We typically can have internal hard drives or external hard drives. And our internal hard drives are typically a larger capacity. Although nowadays with what we can buy, you can get external hard drives with as much capacity or even more capacity than might be currently inside of your computer. But on Windows, your internal hard drive is typically your C drive. External hard drives, you use a USB port or some other type of cable to connect to your computer. And typically we use them for backing up data or just to have a little bit of extra storage to put some files on that maybe you don't access that often. But when it comes to a hard drive, this is actually a pretty good picture because it shows one opened up here. Our internal hard disk shows our standard HDD open. So we can see inside of it. We have this little arm here. And that arm is your reader in your internal hard disk. That's what goes and gets the data. And all the data is stored on these plates or platters. And so when we think about a hard disk, we have a series of platters. So that one plate or platter that you see there on top, there are a few more of those stacked up underneath it. And that arm travels between all of these layers to go get data depending on where it's at. And we'll talk more about like the retrieval of data and that sort of thing next week. But we'll finish it off in comparing hard drives with solid state drives. That'll be the last place where we'll kind of sit for today, because we're already over time on our live stream. A solid state drive is relatively newer to computers, but we're starting to see them more and more in our computer options. And solid state drives are based on flash memory. So they're essentially a scaled up version of a flash drive. So when we look at when we look at a solid state drive, there aren't any moving parts like there are in a hard drive. This is chip based. It's more durable. It's lightweight. There's no noise. There's less power consumption. And as a result, it's a whole lot faster. So if you want faster read-write speeds to and from your hard drive, to and from your main storage, which is usually desirable because it helps things run a little bit faster, then ideally you would want one of these solid state drives to be your main internal storage device. Because you're going to get that speed, you're going to get that reliability, that durability from that device. So that's pretty great. So as I've said in the past, I don't like to go any more than about 30 to 45 minutes with these live streams. So we're pushing right up against like the long time here. So I'm going to go ahead and end this here. I'm going to hang out in the chat just for a couple minutes, just in case anybody watching with me live has any questions. But if you're watching this later, or you think of a question later, feel free to send me an email and ask. But that's all that I have for you today. Remember that Module 3 is due on Sunday, 11:59 p.m. That's all that I have for you for today. Thank you for watching, and we'll see you next time.